Analysis 1 and 2. Actually, if you want to prepare well, in the pre-BAC, we, the teachers from EEB4, included almost everything that we've seen in the BAC questions. Most of the questions were just to know how to use the calculator, of course. On the real BAC questions, you first have to understand what you are asked to do and then to use the calculator. But for the calculator functions, to do part B, for example, from 2018 is a good exercise. That's why I will solve this with you now. Okay, the question is, consider the function. Okay, again, let me remind you something. Always start with new question, with file, new document. So in this case, you're asked to save or not, but if you don't want to, if you save it, I think in test mode you still can save, and then you can go back to the question. So save it, and then I will not save it now. But okay, I will start with new document. I will add calculator page. Consider the functions defined. Let's first define the functions. F of x. Do not forget to click here, not equal sign, but this sign. F of x is x to the power of 3 minus 3x minus 2. This is f of x. G of x. Let's define g of x. Again, this function, control and this sign. G of x is equal to x minus 2. Find the coordinates. We already have these two functions. Find the coordinates of the points of intersection of f of x with x-axis and the y-axis. The easiest method, of course, is to draw the graphs. F of x and g of x. But first, find the coordinates f of x with the x-axis. So here we have intersection points. How can we find them? Menu, analyze graph, intersection. We select the graph and we select the, here it's written second graph, so if I click here it doesn't work. So either I need a x equals 0, a y equals 0 as x as an x-axis, or something else, but I really need second graph. If I don't know the second graph and I don't want to write second graph, I can use zeros. 0, when I click 0, from here to here I have 1 0, minus 1 to 0, menu, analyze graph, 0, from here to here I have another 0. This is also possible. So these are the 2 points, and find the coordinates point f of x with x and y. We have one more point here, so this is when x is equal to 0. By the way, when x is 0, 0, 0, minus 2. So 0 minus 2 is also 0 minus 2 is the y-intercept. This is the y-intercept. Find the values of c. Sketch the graph. Of course, you can sketch the graph. When you sketch the graph, you always put the x-intercepts and the y-intercept, 0, minus 2 in this case. So x-intercepts, y-intercept, and yeah. Normally we also write these local maximum and minimums of the function, the extremes. Find the values of c such that the equation f of x equals c has exactly 2 solutions. F of x equals c. F of x is the first function. The second function is y equals c. Y equals c is a horizontal line. I don't know where c is, but of course, to have exactly 2 solutions, we are in this case. This is c. We have 2 solutions here and 2 solutions here. So c equals 0 is obvious. But the other solution, we have to find the minimum in this point, minimum value, analyze graph, minimum is from here to here, we have minimum, and the point is with coordinates 1 and -4, 1 shows the x-axis, -4 shows the y-axis. -4 is the value of the function when x is equal to 1, so -4 is c equals -4 and c equals 0. Also here, when you click menu analyze graph, you can find zeros, you know already. Minimum or maximum is this, you already know. Intersection, yes, for intersection we need two graphs. That's why the next question is the next is something else, but if we have the second graph, we can find the intersection points between two graphs. Inflection, we haven't done this yet, but inflection is where the function changes the curve from forgot the verb. Okay, dy dx is the derivative integral. Bounded area is very useful, we will do this. Okay, find the equation of the tangent to the graph at the point x equals -2. You know how to do this without a calculator, but in the calculator you have a function. It's a tangent line. If you don't know how to write this and what the syntax is of the functions, when you click here, you have all the functions. So go just to, when you click T, it's tangent line. When it's click tangent line, it's written expression, variable, value. So expression is the function, variable is x equals -2. So x and -2 is the value. So tangent line for f of x, which is x cubed minus 3x minus 2. The variable is x and the value is -2. And you have the tangent line y equals 9x plus 4. Here you have also given the function. Yes, I could write f of x because f of x is already defined. And then in many years we've seen questions like this, that the solid is formed by something, and this is the formula for finding the volume of this solid. So this formula is always given on the questions. Sometimes you don't know how much x1 and x2 is. In this case it's given. If you don't know them, for example, their intersection points, first you have to find the intersection points, but in this case it's given. So just calculate pi. You can use pi times, or you can use pi from here, pi times integral from a to b, menu, calculus, integral from -1 to 2, and then you have f of x squared, f of x in brackets squared dx. And this is the question. If you want to find the approximate number, it's Control Enter and you have it. The arc of the length is calculated by this way again, integral you have to click on menu, calculus, integral from -1 to 2, and then square root, control, square root 1 plus. So be careful here. First you have to find the derivative and then to square. So menu, calculus, derivative dx df of x, and then I will put all these in brackets, and then to the power of 2 dx. That's it. Sketch the graph g of x and find the points of intersection. It's easy. Tab g of x, and I have the 3 points of intersection. Menu, analyze graph, intersection from here to here, from here to here, from here to here. The area bounded, you know, this is the formula for finding the area between two graphs. That's why I will put this here, but on the exam it's possible not to have the formula, but it's always, this is the formula. You can revise this from here. Back calculator or non-calculator. Area of the shaded region, bounded area. Yeah. When you have these two, it's from 3 to 5 and it's in absolute value. F of x minus g of x. It's always the above function minus the below function, but when you put absolute value, both are possible. And then, what was the question? Oh, pre-back 2018. So from 0 to 2, menu, calculus, integral, from 0 to 2, absolute value is abs function, f of x minus g of x dx, and it's 4. In analysis 2, we already did this in statistics. You have a scatter plot, you have the we just on the pre-back we combined them, the questions, but here it's the same linear regression. Its growth factor is something that is this number, and we have two regressions, one exponential and one linear, and that's it. Yes, I think for the calculator part